All right.
Then you said
Let's get
I would
started.
kill whoever did it. Yeah.
Okay, that'll work. So,
Yeah, you really do it every day.
do you guys recall? Okay, what this line is called when I draw it from there and
The
I thought that's a really straight one.
that's the
So,
height.
bisector.
okay, it's a height, but it's called an altitude. And by that, it doesn't necessarily bisect, but if it's at a 90-degree angle with the opposite side, it would be like the height from this. If this is the base, this would be the height. But we called it the altitude way back when we did altitudes and angle bisectors and medians and all that stuff. Well, it turns out that when you draw in the altitude, these little triangles that it creates are similar to the big triangle. Which means they're similar to each other. So, like these two triangles are similar, and they're similar to the big triangle. Basically, they all have 90-degree angles, right? This works in the right triangle. So they all share a 90-degree angle, and they also all share another angle. So like, if you look at this triangle, it's got the 90 here, and it's got this angle. And if you look at the big triangle, it's got the 90 here, and it's got this angle. So the two triangles are similar by angle. You guys remember that from yesterday? And you can do a similar trick with this little triangle here. It's got a right angle there. It shares this angle with the big triangle. If these two little ones are similar to the big one, then they're similar to each other. Anyway, similar, everything's similar. But it is kind of flipped around, like this triangle is kind of like the big triangle, but it's upside down. See that? So that makes it a little bit tricky when we're finding our stuff, but let's do an example. Let me put some numbers up here. Let's do 4 and 16 and x and y and z. Is that all we need? Yep, okay. You guys remember how on Monday was it Monday? Or was it Friday? Maybe it was Friday. We solved the missing parts in similar shapes. You guys remember how we did that? Set up proportions.
Yeah.
That was Friday, right? Not yesterday. Anyways, this little leg on this triangle, from there to there, what would that match on the big triangle? X on the little triangle here matches what on the big triangle?
Wait, what? On the Y.
Y. Yeah.
Yeah.
X on the little triangle, like this short leg, matches Y. So this little triangle is like the flipped around version of the big triangle. See how the right angle is in this corner? And on the big triangle it's in this corner? So you got to kind of flip it in your head and move it like this. You guys see what I'm saying?
Yeah.
Here, I'll do a magic trick.
No, don't do a magic trick.
That might take like 5 minutes.
What just happened?
See?
Well, no.
Anyways, these two are similar. The big one and this littler one. Okay, let's see. So X is like this, so that matches Y. 16 on this triangle right here matches what on,
2.
that's a Z.
Z.
Yeah, 16 is like the long leg of this little triangle, it's like right here. And it matches Z, which is the long leg on the big triangle. So we could do 16 over Z. Oh, well, actually,
There's two
We'll use that later. We'll use that later, huh?
There's 216.
Yeah, these two things are the same thing. Remember when I traced it and moved it? They're the same. Anyways, let's see, I think we're gonna have to use. Let's see, 4 on the little triangle matches X. 16 matches Z. I'm missing something here. 20, like if you go all the way from there to there,
Also is Z.
would also go with Z.
That doesn't work. Does it?
Yeah, I think that's the way we have to go. Here we go. So, I will go back to that 16 and Z thing. So, 16 on the little triangle, this long leg equals Z. 16 and Z are matching. And then on the big triangle, the hypotenuse is 20. You guys see that? And then what's the hypotenuse on the little triangle? Z. So the little triangle I put on top here. So on this one, Z would be the hypotenuse for the little triangle. And 20 is the hypotenuse for the big triangle. So that would go down there. And we could solve that. How do we solve that? Cross multiply. 16 times 20. Did I lose you guys on that probably?
So I know we did that, but it's 16 matches Z, how does 20?
Okay. It's hard because they're overlapping. That's why I tried to separate it. But 16 is the long leg on the smaller triangle. This one right here. That is like Z on the big triangle. You guys see that? It's like the back of the chair. I don't know how to describe it. Like, that's what we're looking at. On the little triangle, it's 16. On the big triangle, the whole thing, it's Z. So that's why those two go together.
Oh.
And then if you look at the hypotenuse on the little triangle, the hypotenuse is Z.
And 20.
And on the big triangle, the whole thing is 20.
See it now.
Yeah. It's hard because they're sitting on top of each other,
Yeah, I
right?
just confused lengthwise how like Z can
Mean means average.
big.
What?
Oh, got it.
So then we use our cross multiply trick from Friday. 16 times 20 equals Z times Z. What's Z times Z?
Z squared.
Z squared is how we usually write it. Equals 16 times 20 would be like 320. Then how do we solve that for Z? Square root, right? To get the opposite of a square is a square root. Now, if you plug that in your calculator, you're going to get a decimal, which I'm probably okay with. Another way to do it without a decimal is this method. All the doubles come out, so a 2 comes out, a 2 comes out, a 2 comes out. 2 times 2 times 2 is 8, and then a 5 is left behind. That's probably the answer the book put. I think I'm going to let you guys put a decimal though. We'll say square root of 320 is whatever the decimal version of that is. Would be okay. Anyway, that would just be we just solved for Z here. 8 squared of 5.
And we still have to solve for the other ones.
Yeah.
That's so much.
Yeah, now that we have Z, that's probably going to use that in the other one. So, X, on this, let's see.
Write this down. I'm hoping on it. Maybe I'm hoping on it. Huh? No, wait, not really.
Okay, X is the short leg on this blue triangle, right?
Mhm.
And on this, this triangle out here, 4 is the short leg. So on the medium triangle and the tiny triangle, X and 4 go together.
And then it would be like,
And then 16 would be the long leg on the medium triangle, and X would be the long leg on the smallest triangle, this one. So, let's see, I put the medium triangle on top over here, so 16 should go on top here. So that can help us with X. This one will come out nicely, because 4 times 16 is 64 equals X squared. So X squared is 64, what's X?
8.
8. And we could kind of, it's not really cheating, but we could kind of cheat and do like 4 squared plus 8 squared equals Y squared, right? That might be a little bit quicker. We could set up another proportion with Y like that. Or we could do Pythagorean theorem, 4 squared plus 8 squared equals Y squared. And do that. Okay, let's look at let's look at page 552. We're doing 1 through 16. That's our goal. I might just go 1 through 15 to save us. But how about number 4 or 5? 5 looks trickier.
They're both a bit tricky.
Let's look at number 4. You guys ready?
4. Really. Oh, close. Ow, ow.
Okay, we did do this in Algebra 1.
I don't remember.
If you weren't here, you probably did it. We didn't do a lot of them, so you might have forgot, but how do we, but what's the general?
Wait.
3 times 4 is 12.
Okay, here's the thing. You do 1 times x minus 1. Really, it's 1 times all of x minus 1, so it's like distributive property. But when you multiply by a 1, it doesn't really do anything, right? So
Yeah, it's just X minus 1.
it's just x minus 1. But on number 5, you do have to use a distributive property. That's the important thing. So x minus 1 equals 12.
It's X equals 15. And then it'll be 13.
We already did 1 through 3 on Friday, so I'm not going to re-explain that. But okay, number 5.
Wait, did you not go further on that last problem?
Yeah, you got to finish it on your own. Number 5, the one we're concerned about. Okay, so what do I do for 5?
The same thing we did for 4.
So how do I set it up?
2x minus.
Nope.
X
I
squared
did that one
minus
wrong.
3x.
Okay, x. Alright, do you guys see how I got that?
X squared minus 3x.
I don't even know what I started saying. Yeah, me neither.
Okay, now this part we're definitely rusty on. How do we solve a quadratic equation?
I don't
Okay, is this x squared plus? No. Oh, wait, you have to get x, wait.
I mean,
Oh, you
remember
gotta put
hating
those 2
this.
x's together,
But
right?
I don't
pretty
remember
simple.
why.
X equals
I
4.
don't remember.
Okay.
4 minus 3 is 1, and then 1 times 2 is 2. And then 2 times
Well,
2 is 4, so 4 minus 3 is 1.
you don't just plug in.
5 by 3?
4 is the only answer that could be.
Okay, you don't want to just plug in stuff until you find something that works, though. You want to be able to have a repeatable process.
So,
Okay, my point is, when the numbers aren't tiny, like 4, you need to know how to do it every time. So on quadratic equations, we move everything to one side
Oh, that's right, and then like factors.
and factor or quadratic formula. Okay, usually we factor because it's easier than quadratic formula. You guys remember quadratic formula?
A squared plus B squared plus.
No, that's negative b.
That. Yeah, that.
Algebra 2 uses that a lot.
Yeah.
Yeah.
So
Which
you guys
ones
will
are
have
the
to
A and the
relearn
B's
that
and
next year.
C's?
Huh?
Which ones are the A's and B's?
A, B, C.
A, B, C.
A, B, C. Okay, anyway, it factors though, so we're just gonna do that. What goes into x squared? What times what? X and x, put that in the front. And then what goes into negative 4, multiplies into negative 4, that adds up to negative 3.
Negative
Negative 1 plus 4 is positive 3.
1. Negative 4 and 1.
Negative 4 plus 1.
I remember this.
Yeah. It's
Now I
been-
remember why I hated this.
Probably been about a year since we've done this. If we FOIL this, what should we get?
Um.
4.
This. If we FOIL this, we should get that. Okay, we're not foiling it though. We're saying what x values would make either of these turn into a 0? Because that would make it answer. What x values would make either of these turn into a 0? 4 or
Negative.
negative 1. Okay, now we're talking x stands for, I've kind of forgotten. Well, the directions say, in geometry we don't have like the length of the triangle is negative 1. So in the directions it says get rid of the negative answers basically. So it's just gonna be 4. In algebra, you do need to know both. You do need to have both answers though. Alright, let's try number 6. Actually, let me pause and for a couple minutes. I want you guys to do 1 through 3, and then we'll do 6. Maybe I'll draw a picture while we're waiting. Kind of a challenging assignment.